Hi, this is part of the instructional video series for the Strategic Decarbonization Assessment Tool, or SDA Tool, being used for the NYSERDA Empire Building Challenge program. This is video 2 of 4. In this section, we'll be going through the Equipment Inventory tab, which is where you'll enter information about your facility's current equipment. At the top of the Equipment Inventory tab, you can find some basic instructions for how to use this tab in this table. The equipment inventory helps to form the basis of the baseline or business as usual forecast for your facility. The inventory should include equipment that represents, in aggregate, 80% or more of the energy use that's allocated to HVAC or domestic hot water, service hot water uses at your building. It can also include major distribution components such as piping or ductwork, particularly if they represent a significant building maintenance expense. You'll enter information about your facility's equipment in this table. Note that blue cells indicate information that's required and that's necessary in order to build up the baseline calculations later on in the tool, whereas the gray cells indicate information that's nice to have, metadata, identifying information, but isn't necessary as far as the calculations go. Starting at the left side of the table and zooming in, this is where you'll enter identifying information about your equipment, the system that it serves, whether that's space heating or air conditioning or water distribution. Metadata such as what the equipment is, its ID or its equipment tag, its location and service area, and the type of system that it is. After that, you'll need to enter some information about this particular equipment's fuel and energy usage. Note that estimates are fine. We understand that you might have limited information about the facility's end uses. Just make the best guess that you can. So enter the fuel source used by that piece of equipment, whether that's steam, electricity, gas, chilled water, etc., and the estimated percentage of that fuel's energy use that this particular piece of equipment represents. For example, if you have a boiler at your facility that uses gas, and it's the only piece of equipment at your facility that does use gas, then this percentage would be 100%. For smaller pieces of equipment, especially ones that use electricity, the percentage is going to be much lower. For example, a circulation pump at your facility might only use a few percent of your total facility's electricity use. Again, estimates are fine. You'll also want to estimate the peak demand associated with that piece of equipment if it is electricity using. And then finally, you'll want to make an estimate of its demand profile. When does this piece of equipment use energy? Is it in the morning, midday, afternoon, nighttime, or is it pretty constant throughout the day? And also whether there's a seasonal demand profile. Is it summer, winter, or constant throughout the year? And this is important because it helps to allocate different types of rates, particularly electricity rates associated with that equipment. For example, a piece of equipment that uses on-peak electricity is going to be more expensive to run than a piece of equipment that uses off-peak electricity, especially if you have a time of use rate. Based on the information that you entered, the tool will estimate the annual emissions associated with that piece of equipment. And if you expand here, you can see that it also fills out other types of energy. So you can cross-check that against submetering data if you have it, for example. And then finally, you'll need to enter equipment upgrade information, the approximate year that this piece of equipment was installed, its estimated replacement cost if you were to replace it like for like, and then finally, the energy savings associated with a minimum efficiency replacement. So if you were to replace this piece of equipment like for like with, say, a piece of equipment that met new code requirements for efficiency, but didn't really go beyond that. So the expectations is that these energy savings are probably going to be pretty low, again, for a like replacement. And then finally, the tool will estimate the monetary value associated with that kind of a like replacement and the emissions reductions. And you can expand out here and see that the tool puts this piece of equipment into different bins for forecasting purposes, whether that's a piece of equipment that needs to be replaced very soon, within 5 years, it's at the end of its expected useful life, or a piece of equipment that needs to be replaced much later. So once you've filled out all of your major equipment in the inventory, we can scroll over to the right and see a couple of graphics that the tool puts out to help you review. The tool categorizes the equipment by those different bins in which it needs to be replaced. Do the pieces of equipment need to be replaced within 5 years, 10 years, 15 years, or longer? You'll need to right-click on this pivot table and click Refresh to update the data, which will then feed into the graphics you can see on the right. And here you can see an estimate of the replacement costs that you put in for those pieces of equipment by replacement horizon, 5 years, 10 years, etc., as well as the energy savings associated with that. And on the right, you can see the energy use or percent of energy use by equipment remaining useful life, both in terms of totals and also by different fuel types, electricity, steam, gas, etc. And this allows you to see how much energy at your facility is consumed by equipment on the basis of when it'll need to be replaced, even under a business as usual scenario. So for example, with the test data that we have inserted here, you can see that a lot of energy at the facility is consumed by equipment that's going to need to be replaced fairly soon, even in a standard business as usual condition. And with that, we wrap up the equipment inventory tab.